2019 ICT past paper paging question, right? So if you consider this question, assume that a 32 kilobyte program is run on a computer having 32 kilobyte of physical memory. The page size of the system is 4 kilobyte. The page table of this process at a particular time is shown on the table below. And they have given some notes, right? So only a few selected fields of each page table entry is shown. The frame number is indicated in binary. That means this frame number is there, no? This frame number is indicated in binary, it seems. The virtual address on page 0 are from 0 to 4095, and on page 1 are from 4096 to 8191, and so on. The present or absent bit, this bit, right, indicates the validity of the entry. If the bit is 1, the entry is valid and can be used. If it is 0, then the relevant virtual page is not in physical memory, right? Now, assume that a 32 kilobyte program is run on a computer having 32 kilobyte of physical memory, right? So now let us discuss this question. So 32 kilobyte of program. So you know that logical address, right? So logical address. So this logical address. So 32 kilobyte it seems, guys. Logical address, they are saying 32 kilobyte. 32 kilobyte. Then they have mentioned that and the page size of the system is 4 kilobyte, right? First of all, 32 kilobyte, right? So now 32 kilobyte means, first of all, let us convert this into byte. Let us convert this into bytes. So 32 kilobyte. So 2 to the power 10 bytes. 2 to the power 10 bytes is going to be 1 kilobyte, right? But here it is 32 kilobytes. Then you know that 2 to the power 5 is going to be 32. 32. Then you can say 2 to the power 15 bytes. 2 to the power 15 bytes, right? 2 to the power 15 bytes. Right. Now 2 to the power 15 bytes means, guys, we know that 15 bits will be used for this logical address, right? Now to explain that, you imagine there is a byte addressable memory, right? You imagine that there is a byte addressable memory, that 8 bytes is the size of that memory. Okay, you imagine there is a byte addressable memory and 8 bytes is the size of that memory. So if 8 bytes is the size of that memory means, guys, okay, in each place there will be 1 byte. So there are 8 addresses possible, right? So this is one address, right? So this is another address, like that. 8 addresses will be there in each place, 1 byte. Right, right. So in each you have 1 byte. So you will be having how many addresses? 8 addresses will be there. So how many bits will be required to create this? How many bits? 3 bits, no, guys. Why 3 bits? Why 3 bits? Why 2 to the power 3? No, my dear. 8. So if there are 8 addresses, right? So 3 bits are required, right? Because 2 to the power 3 is going to be 8, right? So like that, here, how many bits are required? 15 bits will be required. 15 bits, right? So here, logical address will be having a 15 bit, right? 15 bit. 15 bits. You can say 15 bits. Now, you know that logical address, you have page number and the page size. You have the page number and the page size. Page number and page size. So in the question it is given that the page size is 4 kilobyte. 4 kilobyte. Page size is 4 kilobyte. So let us convert that 4 kilobyte also into bytes, right? So 4 kilobyte. So 4 kilobyte in the sense, right? You need to convert it into bytes, right? So 2 to the power 10 bytes is going to be 1 kilobyte, right? But here 4 kilobyte now, so 2 to the power 2, because 2 to the power 2 is going to be 4. So then you require how many bits? 12 bits, right? 12 bits will be required for the page size. 12 bits will be required for the page size. Then altogether there are 15 bits, and page for the page size your requirement bits is 12 bits are required, right, for the page size. Then remaining 3 bits will be allocated for the page number. Remaining 3 bits will be allocated for the page number. Remaining 3 bits will be allocated for the page number, right? Right, now we are done with that. And also they are saying the physical address, right? That is 15 bits, right? They are saying 32 kilobyte. So in the question it is mentioned, assume that a 32 kilobyte program is run on a computer having 32 kilobyte of physical memory, right? Physical memory. So physical memory also will be having 32 kilobyte, right? So physical memory will be having physical addresses, right? Physical address. And as because here also you are having the same 32 KB, here also the same requirement, that is going to be 15 bits will be needed to create this physical address. Then we know that the page size is equal to the frame size, right? Page size is equal to the frame size. So here we'll be having frame number and the frame size. Frame number and the frame size. So for the frame size, 12 bits will be allocated here, because you know that the page size is equal to the frame size, right? 12 bits. Then for the frame number, 3 bits will be allocated. 3 bits will be allocated. So now using 3 bits, guys, using this 3 bit, okay, using these 3 bits, how many pages will be there? How many pages can be created using 3 bits? That is 8 pages. Why 8 pages? 2 to the power 3 is 8. 2 to the power 3 is 8 pages, right? 2 to the power 3 is 8 pages. So 8 pages will be there. 8 pages. Then we know what is the page size. How many bits are allocated for the page size? 12 bits are allocated for the page size. 12 bits are allocated for the page size. So how many addresses will be there? 2 to the power 12. In each page there will be 4096 addresses. 4096 addresses, right? In each page there will be 4096 addresses. Why 4096 addresses? Why, my dear? 2 to the power 12 is going to be 4096, right? 4096. So now let us move on to the question to get a clear idea. So that's what in this question they have mentioned that the frame number is indicated in binary, right? This is indicated in the binary. So the virtual addresses on page 0 are from 0 to 4095. So I told how many addresses will be there? 4096 addresses. So from 0 to 4095, if you take the count, it's going to be 4096, right? We have done that. And on page 1 are from 4096 to 8191 and so on. Fine. Okay. Now what's the question from you? Assume this program requires accessing virtual address 8200. To which physical address will it get transferred to? That is the question, guys. To which physical address will it get transformed to? That is the question, right? So we'll see. So as in the so there are how many pages? I told there will be 8 pages, right? Because 2 to the power 3 is 8. Then first page, right? So first page, and we'll say this as the second page, then third page. So there are 8 pages, right? I'm drawing only 3 now. Okay. So first page you will be having from 0 to how much? From 0 to 4095 addresses, right? From 0 then 4000 up to 4095 there will be addresses, right? That's what it is also mentioned in the question, right? So the virtual addresses on page 0 are from 0 to 4095 and on page 1 are from 4096 to 8191. So page 0 from 0 to 4091 and in page 1 4096 to 8191, right? 8191. Then in page 2 8192 8192 to how much? 12,287. 12,287. Why? Because you know in each page there will be 4096 addresses, right? Right. Now, in logical address you will be having pages. In the physical address, so how many bits are allocated for the frame number? 3 bits. So using 3 bits, how many frames will be created? 2 to the power 3, 8 frames. So there are also 8 frames will be created, right? 8 frames will be created, right? So I'm showing you only 3 frames here. Okay, 3 frames. So they are also the same addresses will be there, right? From first one maybe will be 0 frame 0 to 4095. 4095. Then the first page, sorry, first frame 4096 to 8191. Then frame 2 8192 to 12,287. Okay, will be there because the page size is equal to the frame size, right? Now they are asking, the question is, come to the question, right? So in the question, assume this program requires accessing virtual address 8200 to which physical address will it get transformed to, right? 8200, right? So we know that 8200, right? So it is obviously in the page 2. Why it is in the page 2? Because 8200, right? It is going to be in between 8192 and 12,287. Now let us come to the page table. Let us come to the page table. Now in this page table, the page table of this process at a particular time is shown in the table, on the table below, right? Now in this, you can see that page 2 will be mapped to which frame, guys? Frame 2, no. Why? This is binary, so if you convert the 010 into decimal, you will get 2. You will get 2, right? You will get 2. Then so page 2 will be mapped to the frame 2. So obviously in this is the frame that it will get mapped to, right? That it will get mapped to. The question is to which assume this program requires accessing virtual address 8200, to which address, physical address, will it get transformed to? So to which physical address, guys? To which physical address? So 8200. Why? Because page number, because page size is equal to the frame size. So what's the answer for that? So what's the answer for that? 8200. 8200. 8200.